Yo, what's up everyone? Patrick here. Welcome back. In this next video, in this next example, we're told that the price of an item is discounted by 25%. By what percentage would the discounted price have to be increased by to restore the original price? So notice here we're actually not given any prices to work with. We're just given the discount percentage. And so what I'm going to do is I'm going to introduce two variables. So I'm going to let x equal the original price, so that's the price before it's discounted, and then I'm going to let y equal the discounted price. And so notice what's going to happen is we're going to start with the original price, and then it's going to be discounted by 25%. Meaning that the discounted price is basically going to be 75% of this, right? So if you remember, if you have some kind of old value, and then you'll have 1 plus r, and that's going to give you the new value, where this r here is basically the percentage increase or decrease. And this here has to be in decimals. So notice that we'd have 1. Now, because we're discounting by 25%, it would be a decrease, so the r would be negative, and we'd have 1 minus 0.25. And that's going to give us that discounted price. So notice we'll have x times 0.75, which is equal to y, right? And so we'll have 0.75x is equal to y. Intuitively, it makes sense. So we're starting at the original price. Because we're discounting it by 25%, 75% of that price is going to be the discounted price. And so now what we're going to do, we can actually go about this in multiple ways. So I'll show you two ways to do this. So we have this here, this relationship here between the original price and the discounted price. What we're going to do now is go the other way. And so we'll be going from the discounted price, 1 plus r, to give us the original price. And in this case, because this discounted price is going to be less than the original price, here we have to increase, right? And so what we're going to be solving for is this r over here. And what we can do is we can actually use this relationship and then plug it in here, because notice we have this y here by itself. We're multiplying it by 1 plus r to give us that x, but we know y is equal to 0.75x. So what we can do is we can actually put 0.75x over here in brackets for this y. And we'll have 1 plus r equals x. And now watch what happens. When we divide by 0.75x, we could divide both sides by 0.75x. Notice this is going to cancel out, and notice that the x's will cancel out. And so that's why the prices are not really relevant here. You can use any price you want, because here the x is going to cancel out, that original price is going to cancel out no matter what price you use. And so after all this, what we would end up with is 1 plus r is equal to 1 over 0.75, like that. And continuing this here, what we would get is 1 plus r. 1 divided by 0.75 is 4 over 3 in fractions, or let's work with decimals, 1.3333. And then we bring the 1 over, so r would be 0.3333. And remember, this r here is in decimals. And notice it's a positive, so we're increasing as we expected. And so the increase is 33.33%, like that. So that's the answer, right? That's how much you're going to have to increase that price by. If you take any price, discount it by 25%, you're going to have to take that discounted price, increase it by 33.33% to get the original price. I'll actually show you a numerical example at the end. Now, another way we could have went about this is, instead of using this formula, old times 1 plus r is equal to new, we could have also did that percentage increase is going to be the new minus the old all over the old, like that. Now, we're starting at the discounted price, so this R here we're going to solve is going to be the percentage increase. So we're starting at the discounted price, so the discounted price is the old. And then the new price is going to be the original price. So we're going from the discounted price to the original price. So the old price is the discounted price, the Y, the new price is X. So notice that R would be X minus Y over Y, like that. And that's actually the same thing as this, it's just rearranged. So from here, what we can do, again, we would use this relationship. And instead of plugging in, we can plug in actually 0.75x for the Y here and the Y over here. Let's actually do that. So notice we'd have X minus 0.75x all over 0.75x, like that. And notice this is like a 1x here. So 1x minus 0.75x, those are like terms. That gives us 0.25x over 0.75x. Notice the x's cancel out. And notice 0.25 over 0.75. 0.25 is 1/3 of 0.75. So this would just end up being 1 over 3 or 0.3333, which is what we got over here, which is the same as 33.33%. Remember with this formula, this R here, same as with this formula, is going to be in decimals. So you got to take the decimal, convert it to a percentage, right? So that's another way we could have done it. So whichever way you do it, 33.33% is the answer. Now, if you tried this with actual numbers, you could take yourself through a scenario. So you can go like, okay, let's say we start with 180. That's the original price. And let's say we discount it by 25%. So what's 25% of 180? Well, that's going to be 45. Right? So we're going to discount this by $45 by 25% of 180. So the new price, the discounted price rather, is going to be 135. And now we got to figure out by what amount do we grow 135 to get to 180. And what you would see here is that when you divide by 135, 180 divided by 135 will give you 1.333 minus the 1, and you get that same R value. Or if we use the 100 over here, discount by 25%, so we're taking $25, that's obvious. So the discounted price would be 75, then you put 75 here. By what amount do we have to increase from 75 to get to 100? Same thing, 100 divided by 75 would give you 1.33. That's why that price doesn't matter, because those x's, if you remember, they cancel out. All right, so 33.33% is the answer.